Well, good morning. As Carla said, my name is Alexander Gabriel Marquez Thierry, and this summer I researched lakes and reservoirs in Colorado. The reason being is we have a lot of lakes and reservoirs. We're very mountainous, we're very flat, we're very arid. Our climate changes all the time, and also we're going through a lot of climate change. So it's very important to see what our water is doing to keep us alive, keep us happy, keep us healthy. So kind of why should we care? Show me some statistics on what's actually happening in Colorado. So this is a little snapshot from the U.S. Drought Monitor in Colorado. This was July 22nd, 2025, so about a week and a half ago. Here you can see on the west side of Colorado, we have a lot of drought going into the extreme drought too. And what that kind of means is that we don't have a lot of water on the west side of Colorado, so we have to transport a lot from either the east or other parts, and it kind of just throws off a lot of balance. But not just that, historically, this is the Colorado Palmer Hydrological Drought Index. So it goes from 10 to -10. At 10, it means that soil in Colorado is really wet, it's really filled with water. And then at -10, it means there's no water, we're dry, we're in a serious drought. So from 1950 to about 2000, we can see a good seasons of drought and then a lot of good seasons of wet. But then around like 2002, we see big peaks starting to show, and then we see less wet seasons and more drought seasons. So we're trending towards more drought in Colorado, and that somewhat appears like this is a great example, the Colorado River mega drought. So right here on the right, or my right, your left, May 2020, it's pretty full, and then a year later it goes down, so that affects all of us. It affects the water we use to shower, for agriculture, for our food. So how am I going to monitor it? How do I check it? So first I was thinking with some USGS stations on the ground for ground data, but not all of Colorado has stations. So then we also thought about using a new NASA satellite called SWAT to check how it captures it from space. So by comparing these two, first I want to validate SWAT, make sure it reads the same that the USGS ground stations are reading. After that, if we can verify it, we can use it at other lakes and reservoirs that don't have ground stations and hopefully get some quantified data out of those. And then to do all of that, we use Python. It's very big in the research community. So I've been talking about this new satellite, SWAT, and you guys are probably wondering, what is SWAT? So I like to call it a revolutionary eye on Earth's water, which basically means it's a really complicated satellite. And as my mentor once said, it's basically just a supercomputer in space. But so simplified, SWOT means surface, water, and ocean topography. This is a little figure with it. It just simplifies a couple things. So it shows you like it's got GPS, the spacecraft, where it is, how it flies, some of its radars and its wings. So it basically flies around kind of with like two big wings, and it scans these SWATs left to right, just like this, and it scans just the top of the water. So just like it says, the topography of it. A little better example. So it goes and you see the swaths, and it goes around the world and encompasses everything about every 21 days. So this is a Colorado map of all the waters of body it has. I got this from the National Hydrology Dataset. I wasn't able to get a good number when I calculated this of how many lakes it has. But after filtering out all the lakes that had about 10,000 meters cubed of volume or more, I got about 4,000 lakes in Colorado. And after checking out the SWOT data that it had on Colorado, we had about 2,500 lakes. And then after some analysis of the SWOT data, we found out that it sometimes had misinformation or no data. So we figured out how to filter those out, and it brought it down to about 2,300 lakes we could look at. So now we want to cross that over to USGS. So we looked at the USGS stations, and there are 13 in Colorado, but only 2 crossed over with SWOT. So that doesn't really give me a lot of data, so I had to cheat a little bit here and found this little, it's called Lake Maloya down by the border. It's in New Mexico, and it turns out it has a USGS station, and I had some SWOT data. So at least I have three figures to compare now. So how did I compile my figures? How did I do my analysis? So I had to get lake IDs for the SWOT database and station IDs for the USGS database, and that I got through files that my mentor would send, or through the internet, or through my mentor himself. I did all that and compiled it all with Python. Then I would get the raw data from the databases, get them in CSV files, and if you, of those that don't know what CSV files are, like Excel files, so they just got columns and a bunch of numbers. And I also did that all with Python. And then I would combine both CSV files and then get my analysis and results. And again, I did all of that with Python. So validating. So it was all of these 3, and I put that process through each 3 of the stations. So these were the graphs that I got. These blue lines are the USGS station time series. So each USGS station records its lake every 15 minutes. And then the orange dots is the SWOT time series. So it only passes or encompasses the whole Earth every 21 days. So I can see that for the most part, it does get the line, especially John Martin and Fruit Grower Reservoir. And those dots that are really close are within a foot of the actual ground data. But you also see that there's a lot of errors. And part of that was sometimes it could be some of my filtration methods. I might have to look over that again. Or it could be anomalies. Sometimes SWOT will capture clouds or really big raindrops or snowmelt or other hydrological anomalies. And it will skew the data. And right now, a lot of SWOT researchers are working on figuring out how to filter these out. But for the most part, it does follow. So validation-wise, am I confident in it? Like 70 to 80%. Not completely, but it's something to work with and give us an estimate. So after that, after saying, you know what, 75% I trust it. I looked over all the SWOT data I had again for all the lakes in Colorado. And Colorado has a division of water resources, and it's divided into seven divisions of water resources. So what I did is I got all the volume change from each division from 2023 to 2025, and I plotted it here. So a couple of red flags that might be red flags, 75% trustworthy, is this number 1 up here, this division. So this division has a lot of water in it, so it might make sense why it lost a lot. But also, it's Denver's in there, Fort Collins, a lot of metropolitan areas. So the question is that water, where is that water going? Is it going to the other divisions and maybe kind of helping them out? Is it being used up by humans agriculturally? Is it going to the other states? The second little red flag would be Division 7, right down there. So that division is right next to other states. So if that water is being droughted and it's going to the other states, maybe we're overflowing them. We don't know. The other problem with Division 1 is that there's no USGS stations here. So it'd be really good to maybe bring this up and say, hey, there might be a problem here. There might not be 75% trustworthiness. So there's just some red flags that came up from these results. More extra research to look into. So this is the end. So the impact I think I made with this we got a little bit more clarification on SWOT and further validating it. We did get a lot of the accuracy to about 1 foot, but we also proved that a lot of the anomalies still come in. We made new tools, especially with Python. A lot of the data retrieval tools for the database, they didn't exist before. So I created them, and hopefully, I hope other researchers that go into SWOT use my tools. I think further work is more filtration, better ways to get those anomalies out of there. Hopefully my methods and my pipeline of data can be applied to other states and hopefully one day the world, and we can look at everything. And I think another part would be, since I only did SWOT and USGS, I'd like to do maybe other satellites or other ground stations that don't belong to USGS, maybe like drone data too, but to compare it more so we have more data instead of just 3 stations. So in conclusion, SWOT is a new tool. It's very young. It went up 2022 and didn't start recording until 2023, so it's only been up for really 2 years. There's still a lot of teams working on it. I think it can like supercharge water management, hydrology, looking at the ocean too. And lastly, I wanted to thank everyone that made this possible for me. So Rex, Series, CU, and NSF for giving me the chance. USGS, NOAA, and SWOT for giving me the tools and data for me to research this. That handsome gentleman over there, that's my mentor, Toby Minier. These lovely ladies over here, that's the Rex team. And then these awesome people down here is what made my summer. So thank you guys so much.